find the area underneath the curve, so when we're integrating, we need to anti-differentiate and then put in bounds. So determine the area bounded by the curve, defined by the rule y equals to e to the power of negative x plus 3, and the x-axis from 0 to 3, integrate it from 0 to 3, e to the power of negative x. Then go through and integrate it. We get negative e negative x plus 3x. Now remember, we don't need the plus c because we're not trying to find a function, we're just trying to find the difference between the points. So the plus c would disappear anyway. We get negative e to the power of negative 3 plus 3 is 9, and e to the power of 0 is 1, so we have minus 1 plus 0. So this becomes 8 minus 1 over e cubed. Alright, find the area bounded by the curve y equals to x squared minus 1 times x squared minus 4, and the x-axis from negative 2 to 2. Now, just be careful. If you have an area on the top and an area on the bottom, you should always be doing the top minus the bottom. However, you need to do one of two things. You can either A, switch the, so normally we write it from smallest to largest. You can switch it from largest to smallest and subtract it because the area is on the bottom and it's negative. Or you add them, like this one, but you leave it going from smallest to largest. So let's do a quick sketch of this graph. Because we can factor out using difference of two squares, we would have it going from negative 2 to negative 1 to 1 and then to 2. So this one gives you 1, x minus 1. This one gives you x minus 2, x plus 2. Alright. So then we're doing integrals of negative 2 to negative 1 of y. I'm just going to be a bit lazier. I'm just going to write that. You'll see the reason why in a second. And then from negative 1 to 1. And then from 1 to 2. Now, if you do not separate them into separate integrals, you actually skip all the area. So for example, if you go from A to B, it only takes point B minus point A, which means we actually haven't found any of the areas in between. So the reason why we have to separate them into separate integrals is because we're trying to account for the areas in between different sections. All right. By the way, whenever it switches over, it cancels out some of it. So like you can imagine this will cancel out with some of this part, but then the rest of it isn't accounted for. That's the reason why. Okay, back to this. Now, I'm just going to integrate it once only, so then I don't have to redo the whole thing every time. That's the reason why I just wrote y dx. So we have x to the power 4 minus 5x squared plus 4. So if we integrate that, we get x to the power 5 over 5 minus 5 over 3 x cubed plus 4x plus c. So then when we integrate, so then when we sub these in, we'll sub this in. So x to the power 5 over 5 minus 5 over 3 x cubed plus 4x, going from negative 2 to negative 1, plus same thing. And then the last one as well. All right. In the interest of saving time, I'm just going to put that in the cas. So then you will get 32 over 50.